Alright, should we do this? Now, by the way, they always should supply a domain for these questions, right? But because, this has an infinite number of solutions as you go along the x-axis. But, if you didn't get given one, what would you assume?
0 to 360.
Yeah, it's not a bad assumption to make at all. Okay, so let's have a go at this, okay? Now, what can we do with this? Already, like right at the start, you can see you need your double angle expansion, right? So let's see how you're going from this morning. This is a fraction, just to help you out, okay? Something on something is 4 tan x. So, how does the tan double angle expansion begin? Can anyone remember? Yeah?
I'll just say what it is.
Yeah? No. Can you remember? How pointless. Don't read it off. I can read it off. I've memorized it. Has anyone not looked at it already? Yeah, Rachel? Yeah, good. Almost 1 minus. Yep. That's okay. We just learned it, right? You've really got to get these into your brain, yeah? I remember it being really tough because they all look very similar to each other. The main way you will learn these is by using them, okay? And it's also, just write it down. So every time there's a thing that writing does, which typing doesn't. Not that you would type this anyway, because that would actually take forever still. But it actually engages a part of your mind that has to do with memory. So do it, okay? All right, now. What do I do at this point? What options do I have? I'm going to have to probably cross multiply to get this guy over the other side. So I've got 2 tan x, and this is going to be 4 tan x minus 4 tan cubed, right? Okay, now it's tempting to divide through by tan x at this point because it's a common factor and it would get rid of this cube business which looks really gross, right? However, that's going to cause you problems, right? Because, for instance, if I gave you this equation, okay, and you divided through by x, which would be legitimate, you'd say x equal to 1 and that is where you would stop, okay? But you'll know at this point, this would be a parabola, right, quadratic equation, so you're expecting 2 solutions, okay? Maybe it is that it's a double root, but in this case it's not, which you would reveal if you factorized, right? So instead of dividing through, you'd take one term over, and then you would factorize. And then you can see it's not just 1, it's also x equals 0, okay? So, big important rule, don't divide through. Instead, let's gather some like terms and see what happens, okay? So, if I take that 2 tan x over, I've got 2 tan x here, and 4 tan cubed x, okay? Unlike with the tan x, I can actually divide through by 2 because you won't lose any solutions if you divide by just a constant, right? So here I'll have tan x minus, sorry that's terrible, 2 tan cubed x. And the reason why the cube is no big problem is because when you factorize, you end up with this, which is really quite reasonable, okay? So now what we've done is we've used our knowledge of expansions to turn this back into a problem which you knew how to solve in year 10. Okay? But maybe you don't remember what to do at this point. What can you do? I've paused here because I've factorized as far as I can go. Okay? This is a product. There's one of your factors and there's the other one. When you've got a factorizing problem like this, much like here, you take both sides, or both factors, sorry, you say this can be equal to 0, and then this can be equal to 0. So, I'm going to break it apart into 2. I'm going to solve tan x, that's one factor, that can be 0. Or this guy, 1 minus 2 tan squared x equals 0, that's my other factor which could also be equal to 0. Okay, now, tan x equals 0. What's the first place your brain goes to solve that? What would you do? 0, okay. What else? We are in degrees, 180, and 360. Okay, now, and that's it. That's all of the domain that we've covered, so we're done. Okay. Now, it's interesting. I'm just watching you sort of go, which is the sound of uncertainty. So how can you know? How can you be really sure? Okay.
I was just imagining drawing.
That's the sound the graph makes in my head. You know? Okay. I asked for that. Okay? Here's what I suggest you do instead. Okay. Now some of you will not like this approach because you do not like what it requires. However, you're going to need to get good at this anyway, so I figure you might as well. The way I approach this in my brain, rather than making sounds, is I graph it. Okay, now, tan x equals 0. Tan x is such a common curve, you really ought to know what it looks like. Okay, so if you're like, man, this thing takes so long, treat it as an investment, because the more times you do this, the quicker you will get at doing it. Okay, until the point where you can see it in your head without actually drawing it. Now, between 0 and 360, what does tan x look like? Okay, well, you've got one branch. And then see, that sound was totally unrealistic because this graph has discontinuities in it, right? Don't try, please. Can anyone beatbox dubstep? Anyway, so there's 0 to 360, okay? And I'm interested in when that graph is equal to 0.